So, page 477. All right. So let's look at flip to the next page, actually. Page 478. We're skipping there. Here we go. So we have these two functions, x plus 2, x squared plus 3x plus 2 over x plus 1. So let's graph x plus 2. I want to see if you can graph x plus 2. What does x plus 2 look like? What kind of line? Ooh, fancy. All right. What's the slope of x plus 2? 0. Oh my gosh. You're doing so well. What's the slope of x plus 2? Nothing. I just rolled my eyes at that answer. Y is equal to mx plus b. What's the slope of x plus 2? Thank you. What's the y-intercept? So x plus 2 has a y-intercept of 2 and a slope of 1. If it's a slope of 1, what is slope equal to? 1 over 1, rise over run, right? So I go up 1 over 1. This is grade 10 math, people. If you're taking calculus, you need to remember that. We use it all the time. Okay, so we got that. Now, look at the second equation. X squared plus 3x plus 2 over x plus 1. Right away, what do you want to write? What? Okay, you want to factor it?
I said it's a quadratic.
Okay. It's not a quadratic, though.
That b over b.
Yeah, so the numerator looks like a quadratic, but because it's a rational expression, it's not a quadratic. Okay? So, initially, when you look at it, you want to go and have a vertical asymptote at -1. What makes the bottom 0? However, the very first step when you're dealing with these things is to always factor. So if I factor the numerator, what do I get?
X plus.
You realize the only thing we've done so far is like math 10, right? X plus 1, x plus 2 over x plus 1. Oh my gosh, what's going to happen? Boom. So if they cancel, it is not a vertical asymptote. Let me reiterate that. If it cancels, it is not a vertical asymptote. However, you still have a domain restriction because I cannot put -1 into this equation. It all blows up. Okay? You have to go by the way the original is written to get your restrictions. But you always simplify to graph. Does that make sense?
Yeah.
Okay. So what does this graph look like?
The same as before.
It's this graph, right? However, we have a domain restriction at -1. So it's called a POD, a point of discontinuity. It's a hole. Okay? So whatever cancels creates the open spot in the graph because it's still a restriction. It is a blank little space on the graph. So x cannot equal -1. To get the y value of the POD, plug it into what's left over. What's left over? So the y value is going to be -1 plus 2, which is 1. So that means our POD is at 1 and 1. So at 1 and 1 on the graph, we have a hole. Or -1, sorry. I wrote it in the wrong spot. There you go.
You got -1 plus 2.
I just put our POD, our domain restriction, into what's left over. Into what's left over. Okay?
And those are our restrictions.
So that is our restriction. So we get -1 and 1. It's still this graph, x plus 2. So it's a straight line, just like the one over here. It has a y-intercept of 2, up 1, over 1. So we look like it's a straight line with a little open spot in the graph, a hole. It's got an opening in the graph. And you have to draw the open circle. And if you want it to be clear that I know what you're talking about, so you get marks, you can just literally draw an arrow and go, that's a POD. That's a really bad arrow. There you go. POD. Whatever cancels is your POD. All right? I think we can get one more done, a couple more done. I know. Can I scroll down? Boom. Okay, here we go. Consider the function g of x is equal to x squared minus 4x plus 3 over x minus 3. Okay. What's the very first thing you do? Factor it. What multiplies or factor the top? What is the top factor to? What cancels out? The x minus 3's. So, what is my domain restriction? No. What is my domain restriction? X cannot equal 3. You always look at the original. How do you get what is the POD coordinates? So the point of discontinuity, you put x is equal to 3 into what's left over, which is 2. So the coordinates of your POD are x, y, 3, and 2. This is the POD. So we can actually sketch that graph. You know what? We're going to keep going. Because then that'll make tomorrow easier. And then, yeah, we're doing this. All right. Can I skip? Does that make sense?
Sure. Actually, yeah.
All right. Boom, boom, boom. Nope. Look at this, baby. This is the last thing we're doing today. All right. Now, in real world stuff, however, we're not in the real world. We're in pre-calc 12 classroom where everything is rigged for your pleasure. What would you have to do to this? You'd have to factor it, but that's a cubic. Do you remember the unit? How do you factor cubics?
That's you have x plus something and then the big ass.
Find all the factors of this, divide by all the factors of that, and then you plug it in, and if the remainder is 0, you can factor it. I'm not going to ask you to do that. I'm just going to give it to you in factored form. So if you factor the numerator and the denominator, you end up with this. No. All right. So I get that. What cancels? 2x plus 5's. Bye-bye. What else? X plus 1's. Boom. You're left with? Okay. Where are your PODs? How many PODs do we have? You have 2 of them. Right? It's the stuff that cancels. So, our PODs occur at x is equal to -1 and what's the other one? -5/2, which for the people that like decimals is -2.5. All right, how do you find your y value of the POD? So for the first one here, -1 minus 3 is -4. So we have a POD at -1, -4. There's one of them. What about the next one? -2.5 minus 3, which is negative 5.5. So you have one at -2.5 and -5.5. So you have 2 PODs. What does this graph look like? There you go. But it has a y-intercept at -3. Slope of up 1/1. Guesstimate where that is. -1, -4. We're just saying that. -2.5 and -5.5. Obviously, I will give you graph paper. There's your graph. All right. Numbers 1 to 3, please. Because 2 of the factors canceled. Numbers 1 to 3, just sketch it. I'll post. Do they have the answers in the back? Yep, they have the answers in the back for this one. So 1 to 3, just sketch them. Indicate the PODs. Tomorrow, we take everything and we put it all together. So we take ones that have vertical asymptotes and PODs and we sketch those. And then we're going to do a working backwards where I give you the graph and you have to generate the equation, which is actually sounds complicated. It's actually pretty easy. That's your questions. We're almost done the unit. You're almost done the course. Exciting stuff. I know.